Now, do me one favor. Make sure you like, you share, but more and more, make sure you subscribe to my YouTube channel. Teacher Kyle Explains. It contains a lot of things, especially that are meant for our learners in school. Now, without much ado, let's go directly into our class. Thank you. Now, thank you so much. Now, in this one here, we will look at the effect of heat on substances. Now, there are three states of matter. There is solid, liquid, and gas. And all these ones here, there is how the heat affects them. Now, the first thing that we need to look into is naphthalene. Naphthalene, remember, is a solid. Therefore, we need to understand what happens in the naphthalene. Here, there is a thermometer whose work is to record the temperature of naphthalene, the temperature at which naphthalene melts. We have naphthalene itself here, which is our solid, and here there is our source of heat. Now, during heating process, here we can actually see that when you heat, then the temperature will rise steadily, then the melting will occur. There is also a point in which the temperature will remain constant, and all this one is to ensure that everything of naphthalene has melted, as we all know. Now, if we were to represent this thing here to represent it in terms of a graph, so the graph here is from A, B, C, and D. Therefore, that means that at A, B, the temperature, there are 2 points, key points that you need to take into consideration. Number one is that this temperature will increase steadily. And number two, the kinetic energy will also increase. The moment the kinetic energy increases, then that means that we will have the vibration and increase the movement of those particles. They will move very fast. At the same time, at BC, now at this point now, this is where the temperature remains constant. Why? Because we need to make sure that all of that naphthalene, the solid, has actually melted. It is at this point now where now we are saying that the forces of attraction, which are holding one particle and another particle, have been broken. At this point now, the state changes. It changes now from the solid to liquid because the forces of attractions have been broken. Now, at CD, it is the same thing actually that happened at AB. So that means AB is the same as CD, because at CD also the temperature will rise steadily. At the same time, we are also saying that there will be an increase in the kinetic energy of the molecules, and therefore that means that the liquid particles here, the liquid particles will be at a position to absorb that heat. After it has absorbed that heat, then the kinetic energy increases and they will move very fast. Now, this one here is the heating curve, and this one here is a cooling curve. A heating curve is a sketch of a graph of temperature against time in which the naphthalene is heated, or a substance is heated. This one here is a graph of temperature against time in which the substance is being cooled. So we call it a cooling curve, and this one here is a heating curve. Now, let me go through it once again. We are saying that the state of matter are divided into three. There is solid, liquid, and gas. This one here, the moment you subject heat into the solid, liquid, and gas, there is a change in them. Then naphthalene is our solid. The moment you do the heating process, what happens at AB? An increase in temperature. Kinetic energy also increases. At BC, what happens here? Now at this point, the temperature remains constant, so as to absorb the heat energy that is required to break the force of attraction holding the particles together. And in this place again here, the temperature rises steadily as the liquid molecules absorb heat. Kinetic energy increases, and therefore also the movement of the particles also will move very fast. In this place, this is a heating curve, and this is a cooling curve. Now, we can also have water. Water in here now stands for the liquid, because we've looked at the solid, which is our naphthalene. At our place here now, we need to understand that for sure when you heat water, there is an increase in the temperature. That means also the kinetic energy increases. One thing that you need to understand is that an increase in temperature also increases the kinetic energy of the molecules. Then it will reach a point now where now the temperature will again remain constant. At that point, the energy that is supplied will be used to break the forces of attraction that is holding the molecules together. The moment the forces of attractions have been broken, then those water molecules will now change their state from being liquid into the gaseous state. There are two key points, or rather even 3 points: temperature rising steadily, kinetic energy increasing, breaking of the forces of attraction, and the change of the state from solid to liquid. And this one here, again, this is our graph. This is our heating curve, One thing that you need to understand is that whatever has been shown here is what I showed you in the previous classes, that from the solid to liquid to gas. What you need to understand is that these are processes which usually take place, but they are usually most of the time used for us to understand what happens when the heat is applied into a substance. That is what you need to understand and know concerning that. Now, briefly, I want us to look now into a theory which governs all these things, and we call it what we call the kinetic theory of matter. The question is, what is the kinetic theory of matter? Kinetic is the energy in motion. We all know that one. The kinetic energy is the energy in motion, and therefore it means that when you talk of the kinetic theory of matter, we are talking of matter which is made up of many particles, but those particles are not static, but we are saying that they are in constant random motion, moving from one place to another place. And we can represent that kinetic theory using this model here, where we are saying that we can have the first one, which is standing for the solid, liquid. This one is standing for the gas. And now for this one, which is standing for the liquid, for the solid, we are saying that the particles A, B, C, D, E, and F, and G, all these ones here, these particles are closely packed. In other words, they are together. They are not far away from one another. So if you move from one place to another place, you are moving to another particle. So there is no space that is here. So they are closely packed together. What happens here? The moment you do the heating process, we are saying that the vibration usually takes place in fixed positions. So there is no change in their positions. And when you do the heating process also, their kinetic energy increases. And therefore that means that the vibration of these A, B, C, D, and E, which is a symbol of the particles that we are saying, is that it will also do the vibration. So they will vibrate very fast and they will move. Now it will reach a point where now the forces here have been weakened. And when the forces have been weakened, that means that the melting is going to take place. And that is why we are now talking about the melting point, a point in which the solid changes to liquid. And that is what we refer to as the melting point. How does it occur? It is through the weakening of the forces, which we all need to understand that it comes as a result of the application of heat on that solid particles. Now, if we go to the liquid, we are saying that they are not that close. That is what you need to know. They are not that close as compared to the solids, but they are somehow close to one another, but not compared to the solid particles. Here they have also got their own definite shape, and the forces of attraction also holding these particles together. When they have been subjected into heat, they will be broken. The moment they are broken, now it will change from the liquid into gas. And that is why now we are talking about the boiling point, the point in which now the liquid changes its state into the gaseous state, which we call it the boiling point. So here there is a melting point, and also here there is what we call the boiling point. Very nice. And this is the gas. Gas has got also 3 things that you need to understand. They are also far away from one another, and they are free also. They are free to move. Now, maybe to do something which is very important for us to understand is that there is what we call the impurities. Impurities, these are things which usually affect most of the times the solid and the liquid. Now for the solid, we are going to look at the melting point, and for the liquid, we are going to look at the boiling point. Now, if you take, for example, naphthalene and camphor will stand as an impurity, and naphthalene is our solid. Naphthalene, most of the times, and also scientifically proven, that it melts at 80.2 degrees Celsius. But the moment you introduce camphor will lower the melting point of this naphthalene. And that is to tell you that therefore what you need to understand is that impurities lower the melting point of solids. of solids. For example, in this graph here, this is pure one, so it is melting at 80.2, but this one is impure. It is melting at a temperature which is below 80.2. So this is where 80.2 is, but it is melting at a temperature which is below that one. Therefore, you need to understand that one. Now, for something that is pure, it has got a sharp melting point. But the one that is impure, this one here in itself has got no sharp melting point, And therefore, camphor is an impurity. It affects the temperature of the solids. Where do we apply this one? We apply in the clearing of an ice. Very good. We also apply in the extraction of metals, which you need to understand that, for example, in the extraction of sodium metal, we also use an impurity for you to extract that metal there. Very quickly to the boiling point. If you take water and salt here is an impurity. This one here is an impurity. It's an impurity. Water is the liquid. So the liquid plus the impurity, there is an effect in the boiling point. How does it affect? If the boiling point of water is at 100, and the moment you put salt in it, then it means that it will boil at a temperature which is more than 100 degrees Celsius. And this is a pure one, and this is an impure one. What brings the difference? It is an impurity. And therefore, in short, we are saying that the moment you take an impurity, you apply into a liquid, the boiling point increases. So impurities lower the melting point. So impurities increase the boiling point. These are pure water, and this is the impure water. What is the criteria for us to understand whether a substance is pure or not? Is by observing their melting point and their boiling point. We are saying that they melt and they boil at specific temperatures. For example, water is supposed to boil at 100 degrees Celsius. Naphthalene is supposed to melt at 80.2. If at all this one goes below, this one goes high, then there is a change there. So that means impurities are present. What is the criteria? What you need to understand here is that pure substances, they melt and boil at specific temperatures. To close our discussion in this day is that we need to understand that whenever you do the heating of the solids, they will also change their color. For example, zinc oxide, it will change from white into yellow. Solid wax, it will change into liquid wax. Solid iodine, which is shiny black, it will undergo sublimation to give you iodine, a vapor. If you enjoyed today's class, and I do believe that you got a lot, you enjoyed. Have you subscribed to my YouTube channel? Please, if not, do it once again. If you cannot do that, you won't see me. Thank you.